Hey everyone, welcome back to this C# tutorial. In this lesson, we are going to learn more about built-in types in C#. Specifically, we are going to take a deeper look at string and numerical data types. In this lesson, we are going to learn escape characters, verbatim literal, converting from a string to numerical data type, different types of numeric data, and different types of floating point data. An escape character is a special character that begins with a backslash. They are used inside the double quotes of standard strings. These characters are used to perform specific functions. For example, if we write console.writeLine and say, this is a line, when we run the program, the console will display the phase, this is a line. If we add to this phase and say, this is another line, when we run the program, we can see that both statements are displayed. However, both statements are on the same line when we want them to be on separate lines. We could use a separate writeLine command to display the two phases. But if we need to do it in the one command, we need to use an escape character to tell the program that the information must be displayed on a new line. The escape character for a new line is a backslash followed by an N. You can see that the color of the escape character has changed on screen to tell us we are now using an escape character. We can now run the program. The two statements now appear on different lines. Also notice that the escape characters are not displayed. If we change the N to a letter T, we can then run the program to see what happens. We can now see that the two statements are on the same line again, but there is a big gap between them. This is because the backslash letter T escape character is used to perform a tab. What if we want to write something like 1, 2, 3, backslash now? We can see that the backslash N is appearing as an escape character, but this isn't our intention. We can run the program to see what happens. You can see that the program interprets the escape character and displays the incorrect information because the backslash N is considered an escape character. These characters are not shown on the console, and the new line command escape sequence causes the O and W to move to a new line. To resolve this, we can use another escape character, which is 2 backslashes. This tells the program that we don't want the backslash to be interpreted as an escape character, and instead we want to physically display one of the backslashes. You can see the escape characters have changed for the backslash into the 2 backslashes. We can run the program again. This time the information was correctly displayed because the 2 backslashes is an escape character that tells the program to display a single backslash. Another important concept to understand when working with strings is called verbatim literal. Verbatim basically means in exactly the same words as were used originally. This will make more sense once we go through an example. That symbol is known as a verbatim identifier and can be placed in front of the opening double quote. The main advantage of this @ symbol is to tell the compiler to ignore escape characters and line breaks. If we want to display a file path inside our console.writeLine command, you can see that we get an error. This is because the compiler thinks we are trying to use an escape sequence because we have a backslash. The compiler is basically looking at \T, \S, and \Y and throwing an error as it doesn't recognize these escape characters. We can get rid of these errors using the 2 backslashes, which is the escape sequence we saw in the previous example. This is used to display a single backslash. When we run this program, we can see that the console displays the file path correctly. However, when we look at the code itself, it doesn't look right and can be difficult to interpret what the string is going to display. If we remove the second backslashes, we can use the @ symbol in front of the string to ignore the escape characters and display the string as it is written. This is best practice and is a lot easier to read. when we run the program. We can see that the program now displays the exact text that was displayed inside the double brackets. The next concept we're going to look at is converting from a string data type to an integer data type. Is if we write console.writeLine and say enter a number, we can then declare a string variable to read the result using console.readLine. We can then use another console.writeLine to ask the user to enter another number. Again, we will declare another string variable and use the console.readLine to store the value. We now have two string variables called A and B. As these will be two numbers, we should be able to add them together. We can try to do this by declaring an integer variable and making it equal to A plus B. However, when we do this, we get an error. This is because A and B are string variables and num is an integer variable. The error appears because we cannot directly convert from a string to an integer. We need to convert the string variables to integers so that we can add them together. We can do this using the int.parse function and placing the variable inside brackets. What this does is parse or convert the string variables into integers. We then add them together and store the result in the integer variable called num. We can use a console.writeLine command to display the value of the integer. We can then run the program. We are asked to enter a number. If we type 4 and press enter, we are asked to enter another number. If we type 5 and press enter again, the program adds the numbers together and displays the result 9. In order to do this, we had to convert the string values that were entered into integer values to allow us to add them together. The int.parse function is the most basic way to do this. However, this isn't best practice as the program can easily fail if we try to convert something that isn't a number into a number. For example, if we typed a letter into the program when it asked us to enter a number, this is just a simple example to show you how data can be converted from one type to another. We will look at error handling in later lessons. Next, we are going to take a closer look at numerical data types. If we go to Google and search for Learn Microsoft C# Integral Data, and click on the link for learnmicrosoft.com. This is a great resource to use when you are learning C#. There is a lot of useful information that can help you on your journey. If we scroll down, we can see a list of the different integral types that are included in C#. As you can see, each type has a unique range, and this is what you need to consider when choosing the integral type you are going to use. B. You can also see that the different types have different sizes ranging from 8 bits to 64 bits. This makes it important in large programs to select the correct type in order to save memory and CPU performance. If we look at the S byte and the byte types, we can see that they have a range of 256 numbers. The byte allows for negative numbers, so has a range of -128 to +127. The standard byte has a range of 0 to 255. We can see this in our program by typing console.writeLine and typing byte.min value. We can do the same to see the maximum value. We are just going to add a little description so we can understand the results a little better. we can then run the program. As you can see, the minimum and maximum values are displayed. We are going to do the same to display the minimum and maximum value for the byte type. We can run the same commands to test the next set of data types. This is the short and the U short or unsigned short. We can do the same for all the other data types in the table. So we now have a program written that will display the minimum and maximum values for the different types of integral types. We can run this program to see the results. If we compare the results to the list provided to us, we can see that the values are the same. The final data type we are going to look at is the floating point type. We already looked at the double in the last lesson. The float and double are the two most commonly used floating point data types. As mentioned in the previous lesson, a floating point numeric type is used when working with numbers that have decimal points. If we type double, D equals 10.5 with a semicolon. We can then display this on the console by typing console.writeLine and placing the D value in the brackets. We can then run the program. As you can see, the value 10.5 is displayed on the console. If we want to use a float instead of a double, we can type float f equals 1 to 3.45f with a semicolon. You can see that we are using an f after the float number, but we didn't use a d after the double number. This is because every real number in a C# program is treated as a double. To force C# to recognize a number as a float, you must add an f at the end of every float. We can then write another console.writeLine, place the f value in the brackets. We can then run the program. As you can see, the value 123.45 is displayed on the console. We can see that there's a third floating point data type called a decimal. This works in the same way as the float and the double, but is accurate to around 28 digits. This is only required if extreme precision is needed, so we will ignore this for now. In the next lesson, we are going to look at different operators in C#. If you enjoyed this lesson, please like the video and subscribe to the channel, and I will see you in the next lesson.